Hello, my name is Junho Kim from Seoul National University. In this presentation, I will present our paper titled N-ImageNet towards robust fine-grained object recognition with event cameras. Event cameras are neuromorphic sensors that save visual information as a sequence of events. Event cameras have numerous benefits such as high dynamic range, small motion blur, and low latency. Therefore, these cameras are suitable for virtual reality robotics applications where extreme camera motion and lighting change are present. However, the data exhibits a very different format compared to conventional cameras, and it's necessary to collect a dedicated large-scale dataset to utilize the sensor in various real-life scenarios. Further, to fully leverage the benefit of event cameras, the dataset should represent extreme settings with dramatic motion or light changes. We introduce N-ImageNet, a large-scale dataset targeted for robust, fine-grained object recognition with event cameras. The dataset is collected using a programmable hardware in which an event camera moves around the monitor displaying images from ImageNet. N-ImageNet serves as a challenging benchmark for event-based object recognition. The table on the left compares the state-of-the-art accuracy on existing event-based object recognition benchmarks. Most values have plateaued over 90% and tested with a small number of classes. On the other hand, N-ImageNet contains significantly more data with diverse classes, and existing algorithms achieve below 50%, which indicates its difficulty. The figure on the right visually compares the existing datasets by plotting on the axes of number of data and number of classes. Existing datasets either have very scarce classes or limited number of samples. Notice the log scale used for both axes. This is a sharp contrast to the number of datasets available for images, which encouraged the success of modern computer vision algorithms. In addition to the large scale and diversity, N-ImageNet is the first dataset capable of quantifying event classifier robustness. We define robustness as the capacity of event classifiers to produce consistent predictions amidst external changes. This is an important feature for event-based object recognition algorithms to function in the real world. With our programmable hardware, we can create datasets with different trajectories and control the brightness. In total, 5 validation sets are generated under trajectory changes, and 4 validation sets are generated under brightness changes. As presented later, all pre-existing event representations fail to maintain its performance with diverse external conditions presented in our validation sets. To maintain robustness across the N-ImageNet variants, we introduced discounted sorted timestamp image, short for DIST. DIST is a robust event representation that shows resilience against noise due to extreme light condition and camera speed changes. We show visualization results of DIST along with other event representations in 2 distinct setups: original N-ImageNet events versus noisy events obtained in a low light setting. Note that unlike other representations, DIST successfully removes noise, as can be seen in the right. Now we briefly share the experimental results on robustness evaluation. We evaluate various event-based object recognition algorithms on the N-ImageNet variants. Each algorithm is first trained on the N-ImageNet training split and subsequently evaluated on the N-ImageNet variants. The average accuracy in the N-ImageNet variants, which is shown in the rightmost column, is far below that of the original accuracy. This indicates that external changes indeed incur performance degradation. However, DIST constantly outperforms its competitors in most N-ImageNet variants. This demonstrates the effectiveness of DIST as a robust event representation for object recognition. In conclusion, we propose N-ImageNet, a large-scale dataset for robust, fine-grained object recognition with event cameras. N-ImageNet is the largest event-based object recognition dataset to date, and thus serves as a challenging benchmark. Furthermore, N-ImageNet is the first dataset for evaluating event classification robustness in various external conditions. To address robustness, we propose a novel representation of DIST that outperforms all the tested models in N-ImageNet variants. We expect N-ImageNet to foster the development of event-based object recognition algorithms that could readily function in the real world. Thanks for listening.